Hello again. Good morning. My name is Satmer Tapel, and I'm a Cisco instructor and a Cisco instructor trainer. Today, we are going to be looking at Module 2 of our CCNA 3 Enterprise Networking Security and Automation version 7. Now, Module 2 is going to be talking about single area OSPF version 2 configuration. So basically, today's class, we are going to be centering on configuration, hands-on labs. So you join me as we go into it. Don't forget to subscribe to my channel and click like so that as I upload other videos, you will be able to get notification from me. Thank you. So let's move right away. In this particular course, we are going to be looking at how to configure OSPF version 2 router ID. OSPF is open shortest path first. Okay. In the previous lecture, like we rightly said, it's a routing protocol, a dynamic routing protocol, or a set of rules that governs the communication, especially between routers on how they are going to be talking to themselves. So we are going to be looking at how to configure OSPF version 2 router ID. We are also going to be looking at how to configure single area OSPF version 2 in a point-to-point network, right? Now, we'll also be looking at multi-access OSPF networks and configure the OSPF interface priority to influence the DR. Remember DR? DR is designated router. BDR is backup designated router. So we're going to see how we can influence the election of DR and BDR. I'm not talking about election rigging for political parties. I'm just talking about election within routers. So we can even do rigging when it comes to that. So we'll see how we'll rig that. We'll also be looking at how to modify single area OSPF and particularly implementation modification to change the operation of single area OSPF. We're also going to be looking at default route propagation, how we can propagate our default routes in OSPF. And then finally, we will be looking at how to verify a single area OSPF implementation. Well, this topic is quite loaded with configurations and stuff. And so let's get moving. Now, the picture you see here, or the topology you see here, is used for configuring OSPF version 2 in this module. So what we are going to be looking at in our configurations today is 3 routers: router 1, router 2, router 3. And these 3 routers, these are the details, the IP addresses, the interfaces, and stuff like that. This is what we're going to be looking at, and we'll be looking at area 0 as our area. So the routes in the topology having a starting configuration, including interface addresses, like I said. So there is currently no static. There is currently no static routing or dynamic routing configured on any of the routers. So however, all the interfaces on router 1, router 2, and router 3, except the loopback, are within the OSPF backbone area. Remember the backbone area that we talk about? That is area 0. So the ISP router, this is the internet. So this is the ISP router, is used as a gateway. This is our gateway to the internet for our routing domain. Okay. So configuration mode for OSPF is usually enabled using the command router OSPF. So the process ID follows. So you see in this case, once I am in my global configuration mode here, all I need to do is router OSPF, then the process ID. Then once I do that, it changes the mode that I'm in. So I immediately move into a router sub-configuration mode. So the process ID values represent the numbers between 1 and 65,535. So if you use any process ID that is out of this particular range, then you will have issues. All right. So the process ID value is locally significant, and it is considered best practice to use the same process ID in all your OSPF routers. So when you have 3 routers or 4 routers or whatever routers that you have, it is best practice to use the same router ID. So an OSPF router ID is usually a 32-bit value represented as an IP version 4 address. All right, so it's usually used uniquely to identify an OSPF router, and all the OSPF packets include the router ID of that originating route. So it's like a way of identifying the routers and the processes of each of the routers when it comes to OSPF. So generally, every router is required to have its router ID in the OSPF domain. So it can actually be defined by the administrator of that network, or sometimes it is automatically assigned by the router if you, the administrator, have not assigned it. Now, the router ID is generally used as an OSPF-enabled router so that it can participate in the synchronization of OSPF databases, right? So this happens during the exchange state, all right? So the router with the highest router ID will send their database description packets first. So the one with the highest ID sends it first. So another thing that the process ID is actually enabled for or is used for is the election. All right, to participate in election, especially in a multi-access local area network environment. So the router with the highest router ID is then elected as the designated router. Now, if you remember what we said the designated router is, you have a particular router, you have another router in a different area. So if by default, the way OSPF works, the routers are supposed to be sharing their topological changes amongst themselves. So this network might grow, this network might grow. And so if there is any change in this network, maybe the network goes down or so, so the entire router or the routing processes in all the locations are going to now be having this particular update sent to them. Now, it has a way of overwhelming the router processes. Now, the concept of the DR is to say, okay, once the DR, which is in the backbone area, is 0, receives this particular packets, it's the only one that is now having the right to be able to update the other routers about this particular change. So Cisco routers derive the router ID based on one of these criteria. So the first one is that the router ID is explicitly configured using the OSPF router ID, then the ID command. All right, so it is recommended to use this basically. The second thing is that the router uses the highest IP version 4 address of any of its configured loopback interfaces. So if I configure loopbacks on my routers, the loopback interface that has the highest router and the highest IP address, version 4, is basically used for the router ID. The third is that the router chooses the highest active version 4 address of any of its physical interfaces. So that is what it does. But the way it does is that router ID is explicitly configured. If the answer is yes, that is configured by the administrator, then the router uses that particular as its ID. But if you, the administrator, have not configured it, then the router will now check IP version 4 loopback interface, whether it has been configured. So if in the router, there is a loopback interface that has been configured, then the router will check for the highest IP address based on that and will use it as the router ID. But if that is not configured, if you didn't configure your loopback interface, then the router will use the highest active configured IP version 4 on your router as the router ID. So you see, since you already know how this thing happens, the election, you can find a way to read it by putting a higher value as the router ID. So instead of relying on the physical interface, the router ID can be assigned to a loopback interface. Typically, the IP version 4 address for this type of loopback interface should be configured using maybe 32 bits subnet mask. So this effectively creates a host route. So a 32-bit host route would not get advertised as a route to other OSPF routers. So therefore, OSPF does not need to be enabled on an interface that interface to be chosen as the router ID. So how do you then configure the loopback interface as router ID? Very simple. You enter your global configuration mode and type the command interface loopback. Then you give the loopback number, loopback 1, 2, 3, whatever number that you want to give. Then you now assign the IP address to that particular interface. Now notice the subnet mask, it's a /32. That is 255.255.255. That's what we're talking about here, 32 bits generally, okay? So once you do that, you just end. So when you use the command show IP protocols, and then you type it to include router ID, it's going to now give you the router ID as this that you have set. So in our reference topology that I mentioned earlier, the router ID for each router is going to be assigned. I told you that we're going to have 3 routers in our topology, and we're going to be doing the configuration. So in router 1, we're going to use the ID 1.1.1.1. Router 2 will use the ID 2.2.2.2, and router 3 will use the ID 3.3.3.3. So we use the router ID to configure the routers that we are going to see. So first of all, the command is router OSPF 10. 10 is now the process ID that we are going to be using. So if I say router OSPF 10, then I enter the router ID, then I just end. Bam, I finish. As simple as that. All right. So I've shown you how to create it using the loopback interface. You just create the loopback. You say interface loopback, then you give the number, then you give an IP address of that loopback interface. But if you want to configure the router ID direct, you just go to router OSPF, give the process number, then you give it an ID, and then that will be it. But if you want to modify the router ID, so after a router selects a router ID, an active OSPF router does not allow the router ID to be changed until the router is reloaded or the OSPF process is reset. So clearing the OSPF process is the preferred method to reset the router ID. So how do you do that? First of all, you now verify the ID of the router using the command show IP protocols to include router ID. that it gives you. In this case, you see the router ID is 10.10.1.1. So you enter your configuration mode, then you do router OSPF, then the process ID, which is 10, we're going to be using for this lab. Then router ID, then we will give the router ID, like we said, for router 1, we are going to be using this router ID. Okay, then we end. So when you say clear IP OSPF processes, it will ask you reset all OSPF processes, then you use Y to say yes. So it's going to now reset. What is it resetting? From this router ID to this router ID now. So that is how to clear it. So remember the command, you use it in privilege mode, not in global configuration mode. Clear IP OSPF processes. So let's talk about point-to-point OSPF networks. So you can specify the interface that belongs to a point-to-point network by configuring the network command. You can also configure OSPF directly on the interface with the IP OSPF command. Yeah. So the network address and then the wildcard mask is used. As you can see here, I use the command, you're in the global mode and then in the router mode, all right? Then you use the command network, then you use your network address, okay? Then you followed by your wildcard mask address, then the area ID, all right? So you see the network that I do in bold here is a command. Then you see the ones that is in italics is a value I am going to put. This is in italics, it's a value I'm going to put. You see, this is a command, then this is a value I'm going to put. So the network address wildcard mask syntax is used to enable OSPF on interfaces. So any interface on a router that matches this part of the command are enabled to send and receive OSPF packets. So the area ID syntax actually refers to the OSPF area, whether area 0, area 1, area 10, whatever area that you want to use. So when configuring single area OSPF version 2, the network command must be configured with the same area ID on all routers. All right. So although any area ID can be used, but it's best practice to use the same area ID. So this convention makes it easier if the network is later altered to support multi-area OSPF. So how then do we get the wildcard mask? You see, usually the wildcard mask is like the opposite or the inverse of a subnet mask, right? Is the opposite or the inverse of a subnet mask. So the easiest method for calculating it is to subtract the network subnet from 255.255.255.0. So for a/24, a/24 is what? 255.255.255.255.0. This is the subnet mask for /24. Now, if I want to find out the wildcard mask, all I'm just going to put is I'm going to now subtract it from 255. Okay, so if I have 255 all through, so I have 255 here, dot 255 dot 255 dot 255. So if I do my subtraction, what am I going to get? I'm going to get 0.0.0.255. Okay, so that's how it works. So if I have my subnet mask and then I have my /26, for instance, /26 means 26 bits are on. Okay, /24 means 24 bits are on. So if I have, like I said, a /26, it means 26 bits are on. Now, when you have 26 bits are on, what is the subnet mask for 26 bits are on? You see, the easiest way, you see, if I'm subtracting it from 255, 255 means all the bits are on. So I am concentrating on the last octet, because the first octet /26, this is going to be 0, this is going to be 0, this is going to be 0. Then the last octet, this is 0, 0, 0. The last octet is what I'm going to be concerned about. Here, I have 24 bits. So last octet, we have 1, 2, 3, 4, 5, 6, 7, 8. This is 255. All right. And 24, the first, this is 8, 8, 8. That's 24. So it means 2 bits are going to be here. Okay, 2 bits are on. The remainder is 0, 0, 0, 0, 0, 0. So if I do for /26, I'm going to have, this is going to be 1, 1, 1, 1, 1, 1, then 0, 0. Okay, so the question therefore would be, what is now going to be my value here? That's what we are going to now find out when it comes to what do you call it now? Wildcard mask. Okay. So when routing configuration modes, there are 2 ways to identify the interfaces that will participate in the OSPF routing process. The first example, in the first example, the wildcard mask identifies the interface based on the network address. Any active interface that is configured with an IP version 4 address belongs to that network, will participate in the OSPF version 2 routing process. Now, you should note that some iOS versions allow the subnet mask to be entered instead of the wildcard mask. The iOS then converts the subnet mask to a wildcard mask format, but it doesn't apply in all iOS. Okay, it doesn't apply in all iOS. So you need to know how to get the wildcard mask. So if I am doing IP router OSPF 10, then network, this is the network like I'm advertising now, 10.10.1.0. We're going to see the topology very soon. And this is the wildcard mask for what? /24. And you see 0.0.0.255. Then I put my area 0. Then this is the wildcard mask for /30. How did I get the wildcard mask for /30? /30 means that 30 bits are on. Is that not so? So I'm going to have 255.255.255.255. Then I'm going to minus it from /30, which is 255.255.255.252. This is the subnet mask. Okay, so if I do my subtraction, I'm going to do 0.0.0.5 minus 2, going to give me 3. 5 minus 5, 0, 5 minus that, so this is going to give me 3. Okay, so that's how you get the subnet, the wildcard mask in this case. All right, so an alternative is OSPF version 2 can be enabled by specifying the exact interface IP version 4 address using the quad 0 wildcard mask. All right, so entering the network 10.1.1.5, and then you have all zeros here. All right, on router 1 tells the router to enable the gigabit interface this for routing. So the advantage of not specifying the interface is that the wildcard mask calculation is not necessary. Notice that in all cases, the area argument specifies area 0. Now, to configure OSPF directly on the interface, you use the command IP OSPF, then the interface configuration mode command. So this is how you do, you go to your interface, you have to enter the interface, okay? When you enter the interface, then you say IP OSPF, then the process ID, then the area, then area ID. So remove the network commands using the no form of the command, then go to enter. So in this case, I go to my router OSPF10. Remember, we have already advertised these networks. So what you do is you use the no command, then you repeat the command. So it's going to remove this. All right, so it's going to remove it. If you do the same thing for this ones, all right, and it's going to remove the commands. So once you remove the commands, then you're going to now enter the interface. You see, like we said here, you use the interface. So you enter the interface, interface gigabit Ethernet 000, enter the interface, then IP OSPF 10, which is the process ID, then area 0. Once I do that, then I enter the interface that I am advertising, then IP OSPF 10, area 0, then I enter the interface again, the other interface, 0, whatever interface that I'm doing, then IP OSPF 10, area 0. Now, what is passive interface? By default, OSPF messages are forwarded out all OSPF enabled interfaces. However, these messages only need to be sent out interfaces that are connecting to other OSPF enabled routers. So the routers that do not have OSPF enabled on them, they're not supposed to get that particular OSPF messages. So sending out unneeded messages on a LAN affects the network in 3 ways. One is insufficient bandwidth. Why are we specific on LAN? LAN basically tells us that you have your end devices there. So you have your router, then you have your switch here. Okay, so this is your PCs, your PC. This is your LAN, for instance. So OSPF is now configured preferably from router to router. So you can now configure your OSPF like this. So you see this interface here is not supposed to have OSPF configured. So this is your LAN interface. That's what we're talking about. So if you configure it here, it's going to affect your network by insufficient use of bandwidth and then insufficient use of resources. Resources in this case contains like your CPU, your RAM, and stuff like that. All right, and then increase security risk. So without additional OSPF security configurations, OSPF messages can be intercepted with packet sniffing software. All right, so routing updates can be modified and sent back to the router, corrupting the routing table with false metrics that misdirect traffic. All right, so how then do you configure a passive interface? All right, so you enter your process ID, router OSPF, then the process ID, in this case, router OSPF 10, then you say passive-interface, then loopback 0. Now we're using loopback here to symbolize our LAN. Okay, so if you have your LAN, the interface where your LAN is sitting, that's where you now configure, you specify the LAN interface, right? So if I use the command show IP protocols, if I use the command show IP protocols, what am I expected to see? I'm going to see that my OSPF is up with its process ID. I am going to see the router ID. I'm going to see the number of paths and so on and so forth. But most importantly for this, I'm going to see that passive interface has been configured on loopback or on whatever interface that I have done. All right, so the passive interface you're going to see there. So by default, Cisco routers elect designated routers and backup designated routers on Ethernet interfaces, even if there is only one other device on the link. So you can verify that by using the command show IP OSPF, then the interface. In this case, if I say show IP OSPF, then gigabit 000 is going to tell me after the router ID is going to tell me that I am on broadcast. All right. Then it's going to even inform me that this is a designated router. The designated router is 2.2.2.2. This particular router is 1.1.1. Okay. And then you can get through it to this by this address. And it will tell me that the backup designated router is this. So this is the backup designated router. This router 1 is now the backup designated router. All right. So by using that, you are going to now save. But how do you then change it? So to change this to a point-to-point network, you have to use the interface configuration command, IP OSPF network point-to-point, on all interfaces where you want to disable the DR or BDR elections. So if I use point-to-point, it means that it's only 2 routers that are supposed to be communicating within that particular area. So that's what it's going to say. So once I do, it's going to now specify it. Okay. So loopbacks and point-to-points. Use loopbacks to provide additional interfaces to verify of purposes. By default, loopback interfaces are advertised as /32. Okay. So to simulate the real LAN, loopback interfaces can be configured as a point-to-point network to advertise the full network itself. So what router 2 sees when router 1 advertises the network is this. So router 2 is going to see, you see this O is tell us this is OSPF, and then this is what it has learned, and this is the interface it learned through. But most importantly, this is the slash notation. /32 is telling us that this is a loopback interface. Okay. And then router 1, you now configure IP OSPF point-to-point. So you are doing point-to-point between this loopback interface and the other one. Okay. So once you do that on router 1, then router 2 now is going to now see it as /24. You see, it's going to see it as /24. Now we have a packet tracer activity that we want to do now. And in this packet tracer activity, we are going to explicitly configure router IDs like we have seen. We are going to configure the network commands on router 1 using wildcard mask. We're going to configure the network commands on router 2 using the quad 0 wildcard mask. We're going to configure the IP OSPF interface on router 3, and we're going to configure passive interfaces as well. Then we will verify the operations using the show IP protocols and show IP commands. All right, so let's look at how to configure point-to-point single area OSPF configuration. So just a moment. Let me. Okay, so this is the topology. This is the topology that we're going to be using. Like I told you earlier on, this is router 1, this is router 2, and this is router 3. And to the right here, we have a list of activities or steps that is being expected of us. All right, so you see router 1 here has 3 interfaces: gigabit 000, serial 010, and serial 011. So this is router 1. See, this is the gigabit 000 is a LAN interface, and see the IP 192.168.10.0 network. Then this is the other serial interface connecting to another router. This is another serial interface connecting to another router. This is serial 010 here. Okay, and this is serial 011 here. All right, so router 2 also has 3 interfaces. This is the LAN interface, and then it's connected to serial 010 here, and then serial 011 here. I guess, yeah. And this is the router 3. Now, the activity says that the objectives of this activity is to configure the router ID, and then configure networks for OSPF routing, configure passive, and verify this. So let's go into it. So this is the activities that we have. All right, so we start the OSPF routing process on all the 3 processes. So we use the process ID 10. All right, so we'll enter each of the routers, and then we will configure router OSPF, then 10, which is a process ID. All right, then we will have to now create a router ID for each of the routers. For router 1, we'll use 1.1.1, router 2, we'll use 2.2.2, router 3, we'll use 3.3.3. Okay, so that is what we are going to use. All right, so to do that, I will now enter the router. This is the command. Where is it? Router 1. Okay, enter router 1. Then I will say router OSPF 10 in the global configuration mode. Then I will use the router ID command for router 1. So enable, oh, sorry, maybe you're not seeing this. I don't know if you can see this. Let's see. Well, I think this is it. All right, so I think it can be seen. Where is this? Router 1. So I believe you can see it now. So I say enable, then configure terminal. All right, then router OSPF, our process ID is what? 10. Okay, so once you do that, the next thing you're going to do is for us to now put in the what? The router ID command. All right, router -ID, then we'll put 1111. So router ID 1.1.1.1. Okay, so we have assigned the router ID based on where is it? Where is that? Okay, activity. Yeah. Then the next thing we're supposed to do is to do the same thing for router 2 and router 3. So this is router 2. Okay. Let me see. Yes, you can see it. I guess so. All right. So router 2 enable, config terminal, then router OSPF 10, then router ID 2.2.2.2. Then I go to router 3. I do likewise, enable, configure terminal, router OSPF 10, router ID 3.3.3.3. Good. Now, let's come back to the instruction. The instruction says, where is our instruction? The instruction now says, where is it here? Okay. Configure networks for OSPF routing. All right, so they're asking us questions here. How many statements are required to configure OSPF? All right, the answer is what? 3. Okay, we're going to look at it here. The answer is 3. Look at it here, 3. Then second, the LAN attached. Let me see whether you can see it. I've put it in Word. Look at it here. The LAN attached, look at it, the LAN attached to router 1 has a /24 mask. What is the equivalent? The 24 means that is 255.255.255.0. All right, so what is the wildcard mask? Is 0.0.0.255. Okay, for /30, what is the subnet mask? 255.255.255.252. What is the wildcard mask? 0.0.0.3. All right. Then the next thing is they say we should configure the routing process on router 1 with the network statements and wildcard mask that are required to activate OSPF routing for all attached networks. Okay, so the network statement value should be the network or subnet address. All right, so what we're supposed to do is what? Go to our configuration mode, then we go to router OSPF10, which is our process ID. Then we type network, then the network address. So there are about 3 network addresses on router 1. Then the wildcard mask, then the area ID. Okay, so let's come to our topology. This is our topology. So you see here, this is our router 1. So let me do it this way so that we can all follow. Okay, so we can all follow. This is our router 1 here, and you see that's 3 interfaces. This is the 192. This is the 10.1.1. This is 10.1.1.4. All right, so I will enter router 1. Okay, then I will say, okay, I'm in the configuration mode. Network, then 192.168.10.0. This is like 24. Then the wildcard mask, as we said, is 0.0.0.255. Then area 0. Press enter. Then I do the next, let me put it this way, look at it here. The next interface is 10.1.1.0. Look at it here, and it's a /30. So the wildcard mask is 0003. So I'm going to now say network 10.1.1.0, then 0.0.0.3, then area what? 0. Okay, once I do area 0, press enter. Then I do the third one. The third one is what? Network 10.1.1.4. My wildcard mask 0.0.0.3. Area what? 0. Good. So you see, I have done this for the 3 in router 1. So step 2 says we should configure networks routing using the IP addresses and the quad 0 mask. So on router 2, configure OSPF using network commands with IP addresses in the interface and the quad 0 mask. So this is the syntax we're going to use. So you see, we have to now use the IP addresses that are connected to router 2. Let me make it bolder for you to see. All right, so I guess it's better. So I come down here, where's our topology? This is our topology. And then I will enter what? Router 2. So this is router 2. Now you see router 2, I have my LAN 192.168.20.0 network. That is what is here. We're going to now advertise network 192.168.20.1. Why are we using .1? Because we are dealing with the interface. Then 0.0.0.0 area 0. We're using the quad 0, remember. Okay. Then widen this a little. Okay. Next one is network 10.1.1.2 0.0.0.0 area 0. Why are we using 10.1.1.2? We're using the IP address of the interface directly. Then network 10.1. Now you see when we did for 2, look at what we just got a message. We have an adjacency that's been established, and from loading to full on this. Okay? And it has even given us the router ID with router 1. Okay. Then 10.1.1.9, that's the IP address. 0.0.0.0. Remember, we're using quad 0, area 0. Okay. So, right. So we've saved our configuration. What's the next thing to do? Step 3, it says configure the OSPF routing on the router interface. So on router 3, we should configure the required process with OSPF. Which interface on route 3 should be configured on OSPF? The interface on route 3 is serial 010 and serial 011. Look at it here. Where's router 3? Serial 0010 and 011. These are the serial interfaces. So this is what we are gonna do. Okay, let's see, bring up our topology here, and then our configuration on router 3. All right, so in router 3, sorry, where's router 3? This is router 3. On router 3, what do we do? All right. Let's see. Okay. Yeah, we have done the router ID, right? So the next thing is I will exit here, then go to interface gigabit Ethernet 0/0/0. Then IP OSPF 10 process ID, then area 0. Then I'll go to interface serial. Okay, see, I can exit. Interface serial what? 0/1/0. Then IP OSPF 10 area 0. Okay. Then see, I've gotten a full state. Look at it. Got adjacency with router 2. Okay. Then I will now do for router 1 interface serial 0/1/1. Then IP OSPF 10 area what? 0. Okay, so that is now that. Once I'm done with that, then I'm supposed to configure passive interface. Which passive interfaces am I supposed to configure? You remember the passive interface on our LAN interface. So OSPF will send its protocol out through all interfaces that are participating in OSPF process on the links that are not configured to other networks, such as the LANs. Okay, so this unnecessary traffic consumes resources. So the passive interface command will prevent OSPF process from sending unnecessary traffic to the LAN. So which interfaces on router 1, router 2, and router 3 are LAN interfaces? Okay, so we're supposed to now go gigabit 000 on all 3 routers and configure the OSPF process on each of the 3 routers with the passive interface command. Okay, on each of the 3 routers. So what are we going to do now? So I'm going to now go to router 1, router 2, and router 3. So where's router 1? Router 1, this is router 1. So I'm going to say passive interface. Remember, it's our gigabit Ethernet 000. Interface G, gigabit Ethernet 0/0/0. Right? Then I will go to router 2. Router 2. Oh, sorry. I don't know. Am I missing something? Okay. Sorry, let me share my router 2. Or let me just share my screen entirely so that you'll be able to see everything. Okay. All right. So this is router 2 here. So on router 2, I'm going to good. So router 2, passive interface. Passive interface gigabit Ethernet 0/0/0. All right. Then I'll go to my router 3. Router 3. I will go to do the same thing. Passive. Okay, sorry. I'll say router OSPF10. Then passive interface gigabit Ethernet 0/0/0. Good. All right, the next instruction is verify OSPF configuration. So we're going to use the show commands, and we should be able to see that router 1 has these configurations. All right, so where's router 1? This is design. So let's see whether we are right. So sit here. So show, let's say show run. Let's see. Let's see, where is it? Our router. Okay, look at it. Router OSPF10, router ID 111. Then we have our passive configured on Ethernet 0/0/0. We have our network on this. We have this area 0. I think we're good. Is there someone that we missed? Okay, 10.1.1.0. Okay, we didn't advertise network 1.1.4, right? Okay, so we'll sort that one out. Okay, so let's see the other router, router 2. That's router 2. Router 2, we should run. Okay, so router 2. Where did it look at? Where? Router OSPF10, router ID 2222. And then our network is going to 192.20, 191.20, very good. Then 10.1.1.2, good. Then 10.1.1.9. All right, so router 2, we are good. Router 3, let's see what we've gotten there. Router 3, we should run. Okay. This is router 3. Where are you? Configure terminal. Where's our router ID? Oh, I thought we created our router ID. Aha, look at it. Our router ID is created. What else? Our IP OSPF has been configured on each interface. Look at it. Serial 1011, OSPF area 10, area 0. Good. And then look at it. This one, OSPF 10, area 0. So I think we are good. So I think router 1, we're supposed to, I think we missed to advertise network 10.1.1.4, right? Let's see, we missed to advertise. Okay, so let's advertise, configure terminal, router OSPF 10, then network 10.1.1.4, then 0.0.0.3 area 0. Okay, yes, now we have advertised, so it's fully done. So I think we are done. We're done for this. Let me see. Good. See our completion status here, 100%. So let's check our results. So we check your results. Items, good. So these are results. Think so. This lab activity is done and dusted. So we are good. Where is PowerPoint? Okay. All right, so we have done justice to this. Now we are going to pause here and stop the class for now. Then I will now take in the next lesson. Next day, we're going to take in 2.3 multi-access OSPF network. Remember to subscribe to the channel, click like, and then once I upload the remaining videos, you will be able to see. Thank you very much for participating. See you next time.